A love story. This example was originally developed by Steven Strogatz, who I love, and extended thanks to my son's Legos. This is a love story between Lego Jabba the Hutt and his best friend, Lego Rancor. Lego Jabba and Lego Rancor live together, and they're both a bit moody. Their moods change all the time, changing in time, and their moods depend on each other's moods. Let's try to describe this using a two-dimensional system of states where we'll have one state J representing Jabba's mood and the other state R representing Rancor's mood. Of course, this would be much more complicated if we brought in a third character, Lego Salacious Crumb, but maybe we'll tackle that on another day. Alright, so for Lego Jabba and Lego Rancor, their moods can either be positive or negative. If a state is greater than 0, let's say that means a happy mood. And if a state is less than 0, let's consider that to be a sad mood. Before we go on to the state equations, let's make sure that you understand what the states represent by taking a look at some different points in the two-dimensional state space. Here's the state space with Jabba's mood drawn on the x-axis and Rancor's mood drawn on the y-axis. So actually they're the J and the R axis representing Jabba and Rancor. Now I've drawn 4 different dots here. I've got a blue dot in the first quadrant, orange dot in the second quadrant, red dot in the third quadrant, and a green dot in the fourth quadrant. Take a minute to consider what each of these dots represents in terms of Jabba and Rancor's moods in the state space. Alright, so let's see. If this blue dot is in the first quadrant, that means the J variable is positive and the R variable is also positive. That means Rancor and Jabba are both happy when the blue dot is in the first quadrant. In the second quadrant here, we have this orange dot where you're going to see that the J axis is a negative number, but the R axis is still a positive number. What does that mean? That means that Jabba's in a sad mood, but Rancor's still in a happy mood, luckily. Alright, now for the red dot, and if you get what I'm saying, you know that this is the worst dot of all because it means that they're both sad. Jabba is negative and Rancor's also negative, and so everything's kind of negative in Jabba's palace that day. And finally, for the green dot, you can see that the J-axis is a positive value, but on the R-axis we have a negative value. That means Jabba's happy and Rancor's sad. But again, their moods are changing in time. And so what kind of story are we really in for as we start to see how this plays out in time? Let's first assume that Jabba's feelings only respond to how Rancor's feeling, and likewise that Rancor's feelings only respond to how Jabba's feeling. So let's describe that using some state equations. Remember that on the left-hand side, we have notation for J prime, Jabba's mood's rate of change in time, and R prime, which is Rancor's mood's rate of change in time. Alright, so again, Jabba just responds to how Rancor's feeling on any given day. Jabba wakes up in the morning, and he goes over to Rancor, looks down at the pit. Actually, I guess it's more like this, right? And Jabba looks down and he says, "Hey Rancor, how you doing?" If Rancor's happy, that means that the state value R is positive. And if Rancor is happy, that means the rate of change of J prime, is also positive. That means whenever Rancor is in a happy mood, it elevates the mood of Jabba the Hutt. If Jabba was already happy or positive, he'll become even more happy. If Jabba was actually negative or sad at the time, the happiness of Rancor will lift his negative number up, hopefully into positive territory. So his rate of change will increase when R is positive. Then again, if Jabba looks down and Rancor's in a bad mood, Jabba is going to reinforce that mood. This type of feedback, where the rate of change is equal to the state in its positive sense, is the positive feedback. So it's a reinforcing feedback. Okay, so if Rancor is a negative number because Rancor's sad today, that means that J prime, Jabba's mood's rate of change, is going to be negative. That means Jabba's mood is going to decrease. If Rancor's unhappy, if Jabba was happy, he's less happy. If Jabba was sad, he's even more sad. His rate of change is going down. Well, Rancor only responds to Jabba, but he responds in the opposite way. As you can see here, when r prime is equal to negative in front of the j, that negative denotes negative response or negative feedback. Let's see what that means in terms of our little love story. That means that if Jabba's in a happy mood, Jabba's state will be positive. If this number is positive and we multiply it by a negative number, that means that Rancor's rate of change is going to be negative when j is positive. That means if Jabba's happy, Rancor's mood is going to decline. Well, we all know Rancor is stuck down in the Rancor pit, so he really doesn't like looking up and seeing Jabba partying. It makes him mad, and so when Jabba's happy, if he was happy, he gets less happy. If he was sad, he gets even more sad. It brings him down when Jabba's happy. The opposite effect happens when Jabba's feeling bad. If Jabba's in a sad mood, that means that his state is a negative number. And if we multiply that negative number by the negative in front of the j, that means that when Jabba's sad, Rancor's rate of change will be positive. And so whenever Jabba's feeling sad, Rancor gets lifted up a little. If Jabba's feeling sad and Rancor's feeling sad, Rancor will become less sad. If Jabba's feeling sad and Rancor's feeling happy, Rancor is going to feel even less happy. All right, so we've got this situation here, but keep in mind that this is really a ubiquitous situation. I mean, I know I'm talking about Jabba, Lego Jabba and Lego Rancor, but I just as well might have been talking about, let's see if I can get this right, Lego Ross and Lego Joey from Friends. Don't ask me why I have these. I don't know anything about that show, but hopefully somebody finds that funny. Well, sure, all these Legos are well and funny, but you know what's really funny? These are the same exact equations that describe simple undamped harmonic oscillation. Isn't that crazy? That's right. And so if you have some sort of mass attached to a spring and there's no damping going on, you've got this oscillatory behavior where you're going back and forth, back and forth. Those are the same exact equations we're talking about when we have this set of state equations for Jabba and Rancor. And what that means for solutions in this state space is that motions are going to be going round and round in circles, where we're going to be entering each one of these four quadrants in an oscillatory manner. And so we're going to get all those combinations of the four different colored dots we talked about occurring over and over again in an oscillatory manner. Amazing, huh? All right, so now that we've got that talked about, let's start to add in your own personal feedback. Let's say that Jabba and Rancor not only respond to each other, but they start to respond to their own feelings. What does that look like? Let's say, for example, that for Jabba, Jabba's own happiness decreases his mood, and Jabba's sadness increases his mood. Well, that sounds very stable and regulating, doesn't it? You see, if Jabba's in a good mood, he starts to calm down a little bit. And if Jabba's in a sad mood, he tries to cheer himself up a little bit. Jabba always reacts in the opposite of what his mood is. Well, Rancor's not really like that. Rancor's own happiness increases his mood, so if Rancor's happy, he gets elated. He gets even more happy. When Rancor's sad, he really starts to stew, and he gets sadder and sadder and more miserable. So Rancor responds to his own feelings in a reflective way that just increases his happiness when he's happy and increases his sadness when he's sad, which is to say his negative number will get more negative. Here I've got a placeholder for the new state equations, but I haven't filled in the blanks yet. You see what I've done over there is I've written the state equations from this side of the board, and I've left holes to fill in for you to try to fill in some statements of how Jabba's mood's rate of change reacts to his own self. How does Rancor's mood's rate of change react to his own self? So take a minute to try to fill in those holes using whatever terms you think you should. Okay, so let's see how we would do this. Let's see. Jabba, when he's happy, his rate of change goes down. When he's sad, his rate of change goes up. He does the opposite of whatever his state is. That sounds like negative feedback to me. And remember that this is Jabba's reaction to his own state. And so what I'm going to do here is I'm going to add the term minus J because Jabba exhibits negative feedback to his own state. Rancor's doing the opposite thing. When he's happy, he gets even happier. When he's sad, he really bums himself out. And so Rancor's rate of change is exhibiting positive feedback with respect to itself. So I'm going to put a plus R right there. There you go.